Hello, everyone, and thank you for joining us today. My name is James Hansen. I'm the Vice President and Publisher of NextGov, the Federal IT News Division of Government Executive Media Group. It's my great pleasure to welcome you to today's program, On the Edge, the Future of 5G in Government, hosted by AT&T. With the ability to dramatically improve network connectivity by delivering lower latency, improved performance, and increased data bandwidth, 5G is on the cusp of transforming government operations, whether that's enabling hyper-connected smart bases, virtual reality training, near real-time data collection and analysis in the field, or enhanced citizen services. 5G will eventually have the ability to deliver anywhere access to dynamic data. And today, we're exploring the state of 5G in government as it is today, and then talk through how agencies can begin to prepare for the future. And I'm really excited to have some real thought leaders in this space. Before we get started, though, with the program, a few housekeeping items. To the right of your screen, you'll find several icons, including the Q&A tab, which allows you to ask a question. Feel free to submit those throughout the program. You don't have to raise your hand and be called on. Just type it into the Q&A and we'll get to it throughout. So as something comes to mind, please submit a question. Now I'm excited to join and introduce our panelists today. We have Frank Konieczny, the Chief Technology Officer of the Air Force. Frank, thanks for joining us. You want to do a quick intro yourself to our audience and what your role is as CTO of the Air Force?
Sure thing. Hello, everybody. I'm basically CTO for IT. It's all IT. It's everywhere in space now, as well as in aircraft and everything else. And so my job is to bring innovative technologies into the Air Force. And innovative technologies includes AI, ML, quantum technologies, IoT, as well as 5G, which we're going to discuss today.
Awesome. Thanks, Frank, and thanks again for joining. Also joining us is Sal Dietry. Sal is the chairman of the National Spectrum Consortium. Sal, you want to say hi to our audience and tell us, what does the chairman of NSC do?
Thanks for that, and thank you, everyone. Good afternoon. The National Spectrum Consortium is an organization of over 350 companies, and really a group of non-traditional companies. These are the Silicon Valley startups, the innovators, who team with traditional DoD players, public sector players to create innovation across the federal space, but also leverage a lot of that commercial technology, a lot of that commercial innovation that's coming in from the market. So as chairman, I head up the group. We do a lot of collaboration with different agencies, really brainstorming. And then if there's an opportunity, we actually sort of do prototyping of 5G and spectrum technologies, which I always say prototyping makes better policy. So there you go.
Awesome. Thanks, Sal. And I'm excited to hear some of those commercial applications that are being brought to government. Last, we have Owen Rogers. Owen is the AVP for the Technology Office at AT&T. Owen, you want to introduce yourself real quickly and what you do and what the AT&T Technology Office does?
Sure. Thanks, James. So yeah, I'm Owen Rogers, and I'm AT&T's Area Vice President for Engineering and Architecture for the federal government. So my team is made up of design engineers and architects who work with our federal clients as well as our market partners to develop holistic network designs and then to deploy them for federal government customers.
That's fantastic, Owen. So, Owen, let's kick it off with you. Can you provide us with a just state of 5G?
Sure, thanks, James. So we see three major market areas where 5G is now being deployed. The simplest and maybe most traditional is mobile deployments, right? That's where you have this device in your pocket, and today it's 4G, and whether it's tomorrow or next month or next year, at some point it's going to be 5G. We're going to be able to have much greater speeds, much greater density of devices, that kind of thing. But I think it's fairly easy to wrap one's head around it. The next one is a fixed wireless deployment, where you will have devices that are more like traditional routers or other network devices that sit and access the 5G network. And then finally, and probably most revolutionary, are the network edge computing and multi-access edge computing technologies. These are technologies that can interact with endpoints that then have compute power in them. In the network edge computing, this is more than likely going to be for sort of large-scale, geographically dispersed applications. Kind of a traditional example of this is like unmanned aerial vehicles, self-driving cars. That's what's going to use the network edge computing, or NEC, capability. And then there's the multi-access edge computing, or MEC, capability. And this is one that we're going to see a lot of, I think, in the federal government over the next few years, because what it allows you to do is place your network, place your computing elements now physically more close to the endpoints that use them. Over the years, 40 or 50 years, we've had this back and forth, right? IBM with mainframes in the 60s into the client server model, then back into data centers and ultimately to cloud. And we've had this movement to cloud, say, over the last, 10 or 15 years, where data no longer resides near the devices, which is great for things like economies of scale, but can reduce the performance because of latency and geographical disbursement. So when you get into a MEC environment, you're now taking cloud and you're deploying it much closer to the endpoint. So you can now imagine you can do a lot more things with automation, a lot more things that are compute heavy in a low latency type of environment. At the same time, you still have the cloud that's back at your CSP's data center. So that's really where we're going to see an awful lot of innovation over the next few years. At AT&T and with operators like us, our 5G networks are becoming a platform for innovation much more than the actual, I would say, baseline innovation themselves. So new applications and technologies are going to be able to access the network and access resources with a lot greater speed, capacity, and density. If you think about those MEC and NEC environments, the low latency is going to allow you to do things that you've never been able to do before as an application designer, and really allow you to revolutionize your processes too. So that's going to be really I think where we're going to see the innovation. We keep talking about the fourth industrial revolution that's going to be a part of this, and that's really where a lot of that is going to be driven. So where we are today, the testing and uptake are probably greatest in enterprises where the use cases for the greatly improved density, bandwidth, and latency are most clearly defined. So, in government, that comes down to things like defense, which Frank is going to talk about, I'm sure. Medical, we're seeing some uptake in government medical facilities, as well as education. Right, in each one of these cases, you have a really dense, bandwidth-intensive applications that really do look to the capabilities of 5G to make them more efficient, higher performing, and even in a lot of cases bring new capabilities to bear.
That's great, thank you, Owen. That's certainly kind of sets the stage for. And I think we'll dive into kind of each of those focus areas a little bit more. Frank, I'd like to get your thoughts first. We heard, Owen mentioned DoD. Can you give us an overview of how 5G plays in Air Force's current strategy? And then I'm sure we'll broaden out. I know there's a lot of pilots in play across the DoD. Frank, you're on mute. There.
I didn't realize that. I thought I unmuted myself. This is going to be the normal, telecom issue that we're going to have, guys. never fails.
5G can't help the mute button.
Okay. For the Air Force, the overall strategy is we're trying to move LTE 5G to all the bases. This is what we want to do because quality of life, as well as mission responsibilities, we want to make sure that it's sitting at the base level. And so part of this is actually, we've had a leasing opportunity for 10 bases in the Southeast. It's already been out already, that they're currently working and putting LTE and eventually 5G into those bases. We currently have another one coming out, which is 20 bases in the Northwest. Same opportunity. The issue is basically when we give an opportunity like that, we want to make sure we include not only the very populous bases, but the very far-reaching bases that nobody wants to go to. Such as in North Dakota, South Dakota, let's put it that way. So as we do this, the vendor has to come across and say they will provide service for all the bases that we have in the cluster. They also have to have ability to accelerate to 5G. at some point in time and give us a schedule and points. And they also have to tell us that we give them areas that they must cover within the bases. And so the award of the opportunity is basically to basically tell us exactly what they're going to do, and we give them a 25-year lease, which is to give them the return on investments necessary to support them, even going to the bases which are far away that nobody really wants to be at. Okay, that's the overall strategy for the bases. Now, on any basis, we're doing various experiments, and Sal knows that because we're actually using the consortium to actually generate one of those OTA contracts for a prototype. That one is basically Hill Air Force Base. Hill Air Force Base is doing what we call spectrum sharing. Spectrum sharing is a big deal now because the government wants to sell off the spectrum. And that's a great idea, but some of our weapon systems actually utilize the spectrum. And so the idea is, can we effectively share that spectrum with commercial industry in a way that the weapon systems are not really damaged by this and they lose their capabilities? So this is a big deal. We're doing that right now for Hill Air Force Base. We're also going to start doing it with Tinker Air Force Base. The same kind of concept. It's going to be different spectra though. So it's going to be more in the mid-band, maybe a little bit higher. It's going to be more of the condensed spectrum that most of the vendors are actually going to start using for 5G, as opposed to Hill, which is more concerned with the lower spectrum, which is basically where the aircraft and some other capabilities for radars actually exist. And then we have Nellis Air Force Base, kind of interesting. This was another one that came out of the NDAA. Basically, what we wanted to do was to show how you can take a air operations center, which consists of like 20, 30 applications, and they're currently, in a room, move them into a distributed mobile environment where they can move and people can work on those applications in various locations while those locations are actually moving and actually look like they're actually sitting in the same room. So this is kind of like drive your car around and have all these things happening at the same time, and do this with a 5G network with network slicing, some other capabilities, as well as changing the dynamics of how you interact with the applications, including gestures and sound and voice and everything else associated with this. So this is going to be a kind of interesting, new concept of how you would actually interface with, multiple things that can provide information to you very fast, which looks like, some of the movies we've seen a long time ago. So we're going to see that, especially hand gestures. That movie. All right, moving on. We're also working at Hickam Air Force Base. This is kind of interesting because this is aircraft resiliency and maintenance and training. So when we talk about AR, VR applications, this is it, folks. And then some other things too. Resiliency means to us is that when the aircraft comes down and lands, we want to be able to gather all the information off the aircraft about all the engines and what they've been through, and look at the maintenance records automatically with AIML. No one mentioned this too. This is at the edge. We're going to use this data at the edge, at the depots, as opposed to moving it any place else. So the idea is, as the aircraft lands, before it even lands, while it's landing, all the information is pulled off. And with 5G, that's theoretically feasible to actually do that. It's fast enough. So as we progress down the path, we're going to see a lot more of that, and a lot of the aircraft industry is interested in this capability as well. And so it's for both commercial as well as government that we want to use this for. And then again, we talk about smart depots and everything where we'll have internal 5G networks only. We'll have mini clouds there, micro clouds, take your choice of what you want to call them, but they'll be doing the processing into AIML. And eventually we'll get to automatic ordering and everything else associated with logistics we're trying to get to. Lastly, we're doing some work at San Antonio, Joint Base San Antonio. With the Army, we're working with them on telemedicine capabilities and telemedicine training. So this is going to be interesting because we always said it'd be interesting if we could do telemedicine, and 5G, as long as it's resilient, can give us that quick capability, because we always talked about, a surgeon, across the country doing an operation on you. Well, it better be a good network, because obviously it's not, you're going to have a lot of problems. So we're doing that. And the other thing we're doing is in San Antonio, they're doing open RAN analysis and test beds. So they may set up an open RAN test bed any place. And we're talking about maybe doing that at the depots and everything else to test out open RAN and see how it actually works in an environment for various test beds. And so like Hill may be getting an open RAN test bed, as well as Tinker, as well as some of the other bases, as well as we progress down that path. And we're looking at various alternatives to do that. And all this is involved with some technology experiments we're actually doing with IoT devices right now, because a lot of the IoT devices that we have are stupid. I mean, really stupid. They're really old, they're really stupid. And so we're trying to figure out, can we add some hardware to these devices to make them secure? And so we have an authentication capability for these devices, as well as we're adding new IoT sensors to things that never had a sensor before, like motors, where, in fact, we have a Cyber out right now where you can actually, the motor, the vibration from the motor and the heat actually provides electricity for the particular sensor. So there's no other electrical capabilities required for that sensor. And it will transmit out with 5G to particular base stations, and will consolidate the data, you know, at the level. And so as we progress, you see we're trying to do various things, and it's actually supporting, you know, all our missions that we try to do, because that's the main purpose of it. But it has some commercial side to it also. So as we look at it, especially the experiments, there usually are dual use capabilities that actually come out.
That's it. Thank you, Frank. That's a great overview, and a lot of use cases that really accelerate, you know, mission outcomes, which is fantastic and supportive our service members. Sal, let's transition over to you. Obviously, you guys are working with the DoD on some spectrum sharing opportunities, which is integral to launching, you know, 5G experiments. Can you talk through, in addition to the DoD use cases, can you talk through how some applications of 5G are being used in commercial private sector, and where that intersection with government may be?
For sure. Let me start by just touching on the unique nature and process of what we do. And I started out by saying that I think prototyping makes better policy. And I fundamentally believe that. I've been in this spectrum space for about 15 years now. And oftentimes you can sit around trying to create a standard around something without having that something present, without having that sort of playful environment. And that's one thing through the use of the OTA. And the unique sort of collaborative nature where we get together with agencies, DoD, others, even sometimes just members of industry, and throw together white papers and get together and talk about them, government folks, industry folks, in an open forum, and start talking through these things, and then developing, hey, let's think about a prototype, get some things out there, get some things thrown on the wall, and see what sticks and see what we can learn in a very short time frame. Maybe let's say, 16 months, 18 months before you would have a quick prototype. A lot of the work you see in things like 3GPP and others, we're talking about multi-year standards efforts. We're talking about 6G. So that's sort of the long cycle where you get technology. The prototyping, and particularly what we're focused on in 5G, is not only the test bed, which is a real 5G system. They're systems that are reference designs, but the network enhancements that can be possible. So we hear a lot of talk about network slicing, for example. But in our environment, you can bring network slicing, enhancements to network slicing, things that might influence future standards in that area, and bring that to the customer so that they can experience that innovation and also learn from it. I think it's a phenomenal, prototyping is a phenomenal learning opportunity for the customer to get spun up on 5G, to get their hands on it and get moving with it. So in that context, what I see is, in terms of the Smart Warehouse initiative, is an opportunity, and we can probably talk about this later, is to advance the idea of private networks, which are really big and hot right now in the enterprise market commercially, is to bring a network that is a private network and to a smart warehouse, whether that be any agency, or quite frankly, we see a lot of that, I think, as Owen talked about, in the commercial sector as well, and enable them to configure, manage the network, run the network as they need to for the application. So the application doesn't necessarily bend to the network. It's the other way around, where with all of the knobs and whistles of 5G, they're able to develop a system and deploy it and manage it that meets their needs. And that can be across, a number of spectrum. That can be licensed spectrum, that can be millimeter wave spectrum, it could be shared spectrum, it could be unlicensed spectrum. So when you talk about a private network in this context, there's a lot of capability that crosses various agencies. One or two things that I think stand out from the consortium perspective are these IoT networks. I think Frank talked about it. There's a lot of devices out there, RFID readers, other things that are in use, but they're not connected robustly to a network today. Robotics is being introduced into this space. And that's an area where 5G brings about an opportunity. And that's an area where we're bringing in companies from Silicon Valley and other places to sort of look at the problem with how do we innovate? How do we get a prototype up quickly? And then let's add applications down the road. We're doing the same thing with AR, VR, looking at that. And that's an application, as we're on this conference bridge and we're all learning about the new sort of norm that, virtual reality and perhaps augmented reality will play a role in the workforce of the future. And some of the things I'm looking at and considering is if we're talking about deploying AR, VR widely across a training environment, and we've got these edge zones, as Owen talked about, and folks start moving between these technologies, how does all that work? AR, VR today is not necessarily a mobile application that learns on the fly. That's an incredible opportunity ahead of us, and that's the kind of thing we're prototyping. I think is a perfect gem for bringing that AR, VR, and 5G together. So, Frank covered a number of the things that we're working on, but I think this framework is something this prototyping is something we've got to look at as U.S. innovators to keep moving ahead while 3GPP and other standards and other technologies come down the pipe.
That's awesome. Thanks, Sal. But Owen, what are some of the use cases? We've heard of some of the ones that the Air Force is working on, and some of the commercial applications that Sal had mentioned that are coming to government. What use cases of 5G are you kind of bullish on? Are there any examples from a civilian side? I certainly think that there's a number of the applications on the DoD that could easily translate to some civilian missions. Any that you're particularly excited about?
Yeah, so I'll start with one that's not very glamorous, but if anyone on the bridge here has done network backbone management, this will ring true. One of the biggest challenges in terms of network management is planning your overall enterprise network, right? I've worked on some of the largest networks that the federal government has, like USDA, 7,000 locations, Postal Service, upwards of 30,000 locations, and the amount of time that goes into the project management of those networks in terms of getting new sites up and running, the MACDs, right? All of those pieces is immense, and there's a lot of slack that winds up in the system simply because when you go and order a new circuit, right? And these days, that's anywhere from 10 meg up to 100 meg for an edge location, depending on what type of work is being done there. You're talking about usually a minimum of a 30-day turnaround to get something installed, and that really does slow down the overall operations and the nimbleness, if I can invent a new word, for our civilian government friends. One of the things that you're going to be able to do with 5G, with the fixed wireless capability I was talking about, is more or less cut that down to however long it takes to ship a box out to the site. Now, I'm not saying that we would get rid of permanent wireline networks. I think that would be premature. But if you need to get something up and running in a 5G world, you ship the box, and then at the same time you're placing the order, and you have the box up and running as a secondary, what would be ultimately like a secondary or backup, but for the immediate time frame, it can be your primary as you get everything, as you get the wireline circuit ordered. So I think that's going to really help our civilian friends in terms of lowering cycle times and being able to be more nimble in terms of managing their overall locations and their overall IT environment. Number two is, I'll go back to the edge networking that I was talking about. On the civilian side, you go up Constitution Avenue or Independence Avenue, and you have some of the largest office buildings in the world still, right? And they're dotted around the Beltway as well. These are enormous buildings with thousands and thousands of people who work in them. The multi-access edge compute, or MEC technology, I think is going to really change how federal employees who work in those large buildings access and process data. If you work in one of those buildings today, you know that you have to often either you have to connect to Wi-Fi, you have to connect to a wired network. You're entering credentials. It can be burdensome on the end user, and then you also then have to make sure that as a network manager that you're maintaining bandwidth and connectivity to the outside world and doing a whole bunch of other processes. When you have a 5G environment with MAC, those end users will be able to open their device, use their credential, and they are immediately on the network and accessing their data, which is residing locally and updating on the back end. So it makes life a lot less frustrating for end users who are in these buildings. It increases the bandwidth, and with the number of users that are in these buildings, the ability to increase the density of end devices is really important. Wi-Fi is great, but the density that it supports is not certainly not as great as a 5G environment. So that's number two. And then beyond that, I think it would be an open invitation to folks in civilian who obviously cover an immense array of different requirements and capabilities. I would invite everybody to consider how would you improve your processes as an agency if you didn't have the friction of data processing in your back-end IT systems, right? So. Or if you had the ability to see and project yourself out into more places. So one example that my boss, who used to be the CIO at USDA, likes to bring up is the concept of plant inspections, right, at USDA. I think everybody knows that over the years that is an activity that's that the USDA has been unable to cover all of the meat processing plants around the United States. If using 5G, USDA could conduct essentially virtual inspections with constant monitoring and lower the burden on the individual processing plants, lower the burden on its inspectors, have them more centralized, and have them be more efficient. This entire thing would all work out very well for everybody. It's just a question of figuring out where can you find the process improvements. That's one example. You can also look at things like data processing for very large data sets. Our folks at NIH and CDC certainly have their hands full these days, and a 5G environment that allows for rapid movement of data around a facility is another great example of how we could again reduce the friction that's involved in a lot of IT processes. So that's number three, and it really does get down to the individual processes of the agency. But again, I would invite people to sort of with 5G to get creative and try to imagine what it would be like if they could adapt sensors and have the ability to project their IT out to wherever they need to be.
Those are definitely kind of the same, but a little different from some of the use cases that the DoD is doing. So, I mean, I think, Frank, you probably have, in addition to yours, some of those, that speed of process is critical at the Air Force too, and across DoD.
Mm-hmm. Yes, without a doubt, yes. I mean, that's one of the things that we're trying to do. And now that we're in this COVID environment, we're all teleworking. And so it'd be nice if we all had 5G. I mean, really, to actually get things, especially when we start doing video conferencing all the time, it'd be nice if we could actually, not push the networks to its limitations, what we currently have. And so it would help a lot, especially since we moved, since like we have conferences across, the United States. That's just what the Air Force is. And so it's an issue of bringing everybody in and doing things in a more effective way. And I think that would help tremendously to even monitoring, with COVID, is because we get reports in daily as to, if it's up or down and what the bases are going through and what bases are open and what bases are closed. It'd be nice dynamically to get this real time. And that's really difficult right now.
Yeah. Well, also with the pandemic, there's obviously been a lot of focus on the physical safety and health of the nation. And I think, 5G, to one of those key pillar areas that you mentioned, Owen, of accelerating kind of mobile edge computing with IoTs. And, Frank mentioned the ability to add a sensor to almost anything these days. Ellen, what are your thoughts on how 5G can enhance physical safety of the government workforce?
Okay, yeah. So let me preface this by saying that I was advised by our lawyers not to promise that 5G will fix COVID. So putting that aside, what I can say is that we envision that 5G may be able to support a lot of the kind of processes that we are seeing in play as we go out into our public spaces today, right? You go to the grocery store and you're asked to stand 6 feet away from people. You go to some larger buildings now, and they're looking to take your temperature as you walk in the door. And there's been some talk about ideally trying to make sure that we track to make sure that people are staying 6 feet away from each other, and then ideally also track who's come into contact with whom as they move throughout a physical space. So once again, 5G could potentially assist with those kinds of things in terms of tracking of activity, making sure that if two entities are within 6 feet of each other for an extended period of time, and one turns out later to test positive, that we can provide notification, and also then maintain those standards, so making sure that people are moved out from being in proximity with each other in a COVID type of world, right? And then when we talk about physical safety, and I referenced before sort of the idea of trying to reduce the amount of friction that goes into our interaction with various agencies and whatnot. That's where 5G and the ability to process information very quickly and on location, I think, is really going to help people in terms of their day-to-day lives. It really can improve the speed with which people move through security checkpoints, right? Through things like facial recognition, through other forms of scanning. There are airports outside the United States right now that have more or less eliminated the security line because they're conducting security checks on people as they move through physical space, and really does reduce, again, the friction that's involved in security processes. So beyond simply making them more effective, it also does make it more efficient and allows people to live with more security, but at the same time without having to without having it slow them down. That I think is really going to be one of the great things about this, is that, and it all comes back to that ability to process massive amounts of data very quickly and get answers very quickly, so that if somebody moves through a physical space, the answer of whether or not this person has triggered an alarm is achieved in sub-second timeframes, as opposed to having to wait and force people into lines.
How quickly is it? I think you touched a little bit on it earlier, but how quickly is it to set up a 5G network in a particular space like that? I mean, we've seen to the point that you just mentioned, since the Pentagon has gone back to 80% full capacity, they've had a 35% increase in COVID cases. I mean, how quickly could you do that to keep pace with, again, understanding AT&T is not going to solve the COVID crisis, but able to move as quickly as a pandemic like this does?
Yeah, so I think it'd be premature for me to say that we would be able to do it in X number of days, right? Because it really does depend on the facilities, and having done a number of projects up and down Constitution and Independence, and being involved in some projects involving the Pentagon, there's always things like asbestos abatement, and then core drilling and some of older core concrete. So anyway, there's a lot of different things that go into answering a question like that that's very site specific. But we are talking about something that is done on a regular basis with other types of technology, right? That involves site surveys and RF testing, things that we know pretty well how to do. So we aren't really breaking new ground in terms of how you deploy these kinds of things. You're using different technology, different spectrum, but we know how to do these things. So it is not something that requires, say, like significant uplift over traditional installs. It is something, though, that it does very much depend on the physical space in which something's being deployed.
Yeah, no, that makes sense. I was just curious because there's so many important applications of this, just to see at the, the operating at the speed of relevance, kind of, approach
I like
to.
that speed of relevance. Yeah, yeah. And there are, we've gone down this road before, and a lot of these larger buildings with what are called DAS systems, basically internal 4G networks. So in a lot of cases, the conduit and everything is already there. So I don't want to throw cold water on installation timeframes. I think we can get them done very quickly if needed. But it just is very specific to the facility itself.
Yeah. Just a reminder to the audience, if you have questions, please send them in. We'll get to them. We still got a good 20-25 minutes left. So if you have questions, please send them in. So I want to stay on the kind of workforce piece of it. You mentioned earlier the ability for 5G to advance, augmented reality and training capabilities. Can you talk a little bit further about that? What are some other examples that you've seen in other, industries that should ultimately move into government?
Well, and I think it goes both ways, quite frankly. Often we're trying to pull the innovation in from the commercial world into the government. But if you look at technology like millimeter wave, for example, which has tremendous promise as the advent of just massive bandwidth and a way to take us into future upper spectrum bands, perhaps even to the terahertz band from what we learn here. I think that millimeter wave, you look at what the DoD has done in areas like millimeter wave, beam forming, beam steering. These are technologies and approaches that the commercial industry could leverage to move the technologies further down the road. The other thing I would say is that the advent that I see in these private networks, and in particular where you see mixed use of spectrum, including the shared spectrum, for example, it's just the number of new OEMs that you're seeing on the market. U.S. innovators, U.S. companies coming forth with 5G equipment, 5G software stacks, things that we haven't seen before because they're able to come into a private network environment and find their place. And if you look traditionally at the OEM market, it's been in consolidation for a number of years across many verticals. What you're seeing now is an expansion in that area, which is an incredible opportunity for U.S. innovation. And I think across many areas, whether it's public sector, DoD or commercial opportunities for folks to create their own network. And I think that's got a lot of opportunity ahead of it. I would say the IoT network, the ARV network are opportunities that we see and we're engaged in. These campus networks, again, they're private networks, but where you see a lot of this are lighting up stadiums, large venues where traditionally Wi-Fi and 4G coverage might not have met the need. Perhaps you're seeing that in scale now. So whereas before, you've seen a mix of Wi-Fi and LTE at stadiums and events, you're not seeing folks looking to roll 5G out there to give users that experience, more video, more chat, more engagement with the players and things while they're on the field. You see a lot of that at places like Madison Square Garden, where some of these pilots have been lit up, in other areas. Lighting up these campus applications is a big area.
Owen, do you want to? Earlier, you mentioned education as an area around some of the dense applications and bandwidth. Where do you see kind of 5G accelerating AR or virtual training opportunities for government?
Yeah, so I think if you wanted to think about where can we get there fastest, it has to do with those places where training is most critical and the processes have the biggest, let's say, downside if they don't go well, right? And where the greatest risk, essentially, right? So if you can imagine things like training somebody on surgery, right? If you need to train somebody to perform a particular procedure, it'd be nice to be able to do it not on a live not on a live person. So in an AR environment, if you can create something that creates an immersive environment that gives you both visual feedback and haptic feedback, tactile feedback essentially, in an environment that allows somebody to learn without there being the downside risk of error. That's one environment. Staying in the medical field, things like for allied health professions. If you're teaching things like intubation to EMTs or nurses, that's another great way of using an AR or VR type of environment. And then in complex manufacturing, there are large complex manufacturing facilities that are part of U.S. government. If you are able to teach somebody how to operate a machine and not have them use expensive, bring down the machine for expensive training, or have them use expensive materials to learn how to do things, you can keep the manufacturing process going at the same time that you're teaching people a very highly skilled type of activity. So that's really where I see there being that immediate AR VR benefit to training folks.
Frank, do you have anything to add there? Because you mentioned as one of that you guys are piloting a AR opportunity. I think it was you mentioned with the maintenance, predictive maintenance. I'm just fascinated with AR technology in general because you don't see it in application very often, and 5G is certainly, I think, going to accelerate that tremendously, and that's one of why it's so transformational. But can you add? Do you want to add anything about how you kind of see opportunities around AR and where 5G can support that?
Sure. Here's a good example. A mechanic is working in an engine. He doesn't quite understand what's going on. He can't figure it out. What we want to do is call a friend. Call a friend being the manufacturer of the engine, or somebody else, use a SME who understands the engine better. And you want to be able to do that in a way that you can show that engine part or that engine condition to that SME or that repairman from actually built the engine and get it done instantly. Nowadays, you'd have to take a picture, if you're lucky, send it to somebody, get an email back and forth and figuring out what's going on. And it's the typical example that, mechanics don't know everything. And this is the way to augment that mechanic to understand, with the SME out there that says, hey, I understand this, I've had this problem before. Or really the engine manufacturer could look at it and say, well, I never saw that. Let me run a simulation with it right now. And I can run it right in real time. And I can tell you maybe what's happening out there. Maybe you can do some things that could help us together work on a particular problem. This is things we want to get to. We're trying to do this right now with piloting. Pilot training is a big deal. We want to do it in people pilot training, especially when we want to go across with our mission partner environments. We want to be able to link to our mission partners that are also be trained so we can train together in an environment. And this is very difficult unless you have a 5G network supporting this, because the simulations that you have to produce that everybody has to see at the same time and work through the issues are very complex and obviously take a lot of bandwidth. And this is the way to do it. So there's a lot of examples where we believe that, this will actually help us a whole lot now to have to get there and actually put the stuff out there.
So we got the audience is getting active. So I want to get to a number of the questions that have come through. But before we do that, and it may answer some of the questions, let's touch on security real quick. Owen, I'll start with you, and then Sal, and then Frank. So what are the biggest challenges in securing 5G?
So I think first it's worth noting that there's going to be a lot of security improvements in addition to some challenges, right? So 5G security standards include features that'll make it inherently more secure than previous generations. Things like user privacy protection, the stingrays that we've heard so much about in like the 4G environment. You're not going to be able to capture user data using them anymore. We'll be able to, there's a concept called steering of roaming, right? Protocol improvement there is going to help reduce fraud, help reduce roaming costs for end users. So there's a lot of real benefits in terms of security by moving to 5G. but I think that the two sort of like big picture pieces here, where you have some security challenges. Number one is just the scale. You know, we've talked an awful lot about IoT here so far, and we're going to increase we're going to throw a couple of zeros onto the endpoint capacity for the network, right? That's going to increase the threat surface, right, for the number of endpoints that could potentially be compromised. So then you also then have to have security monitoring and tracking of all of those endpoints. And simply that scale is something that hasn't been that hasn't been done before by most organizations. So that's number one, and that really has to do more with the use of the network. And then number two, kind of similar, but there's a little bit of twist to it, is the overall architecture, right? I've talked a lot about edge computing now, which is distributing the assets and the capabilities out to the network edge. They're no longer sitting in a data center or a cloud. That again increases the threat surface, right? If your crown jewels of your organization, the crown jewels of your intellectual property are sitting out in a manufacturing plant, in a hospital environment, there's another possibility, another potential threat for them to walk away. So being able to control data in a distributed architecture is something that folks are going to have to get used to once again, right? It's something that they had to do some time ago. So this model where, again, you've got data at rest in all sorts of different places, people are going to have to be thinking about that from a security architecture perspective as well.
Sal, from your side, what are your kind of biggest security hurdles?
Well, I think as Owen pointed out, it's zero trust architecture, and that's becoming more and more prevalent in the enterprise market as much as it's in the public sector or DoD. We talk about these private networks. We talk about having on-prem private edge zones, edge compute, but these technologies often still reach back to the cloud. And as we look at things like ORAN and other technologies in 5G, that sort of cloud layer now becomes more and more prominent. So the question is, where does that reside, and how does that work? Do you have zero trust proxies on site? How much communication is going back and forth between the cloud and what's happening locally? And I think that's an area where we're going to see a lot of focus in zero trust over the next few years.
Frank, kind of, I know we had a couple questions as I'm looking through these about, what areas 5G security would require the most hardening for DoD use. What are are you guys approaching with some pilots of security question?
Okay, there's a couple things. First of all, the standard that's out there does not mandate all the security requirements. Many of the security in 3GPP releases is optional. So obviously, we're going to have to look at what the implementation of the 5G network is going to be. Second of all, you have to realize that this is a software-defined network concept that can be updated. So you have to look at who is updating it and what are they updating it with, because if it's network, we'll never know it until actually it occurs. So you have to look at that. The real vulnerabilities is at the endpoints. Be it IoT endpoints, be it your phone, be it computer, be it someplace else. So we're looking at what we need to do to harden, to validate the endpoints and make sure that they're authenticated and they're trusted as opposed to anything else. Because obviously you can buy a phone right now that's out there that has a corrupted endpoint. And once it gets into the network, you're dead, no matter what that network is. Now, we always talk about, having various equipment in the network that is not American based. We're living with that right now. Every time we send anything to Europe, we're living with that right now. So we do encrypt everything. That's not the concern. The concern is that after we encrypt it, it's secure across, but the endpoints, again, first part, at the end device and at the application level are where we believe is most vulnerable. And we're looking at alternatives for if we are delayed, in particular, going through a particular network capability that's out there right now, how is this going to manifest it? We're going to have alternatives. And the last piece that we're always worried about is that 5G is not everywhere. So if I set up a network slice in 5G and I send it off and it goes through a 3G network or an LTE or a sub LTE network, what happens to that secure 5G slice? Does it get spread out, and how does it reconstitute itself when it gets to the endpoint? So again, both sides, and sometimes in the middle, you have to look at it. And we're looking at what we can do to secure it and what we can do to evaluate those.
No, that's very helpful, and I think it addresses a number of the questions that we got. One question that, not to go back to the AR VR, because I know, Owen, that you touched on it, but we did get some questions from the VA specifically on what your vision would be for scaling out 5G AR for a healthcare nationwide.
An interesting question. I'd say we can look specifically at the VA, and I'll say a lot of that is going to depend on the Veterans Administration itself. I'm very close with our lead for the Veterans Administration, and I can tell you that he is chomping at the bit to try to get beyond what's been mentioned in the comments, and go further at this point. That's it. It is. I think we have a proof of concept in place, and we're excited to be moving forward. But at this point, we're ready to deploy. I'll just put it that way.
Awesome. Another question that came in, and this might be for Owen, but open it up. At locations where fiber is not currently existing, what is the best way to approach 5G and fixed wireless strategy?
So as of right now, one of our major challenge in terms of 5G today is that a lot of equipment manufacturers are still getting the supply chain up and running, right? So I think it'll be a few months now before we're able to deploy a fixed wireless strategy that, as I was describing, it's kind of like a vision earlier. We are up and running, and I don't want to turn into an ad for AT&T. I think you could probably find similar things for some of our competitors. We are up and running in most major metros around the United States as of this quarter with 5G. So it really becomes a question of can we get the supply chain up and running to start deploying 5G, and that all important thing, the federal government get on contract. Right. So yeah, I mean, that as of right now, I think we are, if you're in a major metro area with a little bit of uplift, 5G should be something that we can start deploying almost immediately.
Awesome. Another question, I'll direct this one to Frank first, but then Sal, I'd love to get your thoughts on it. We got a question on looking at the shared spectrum pilot that you guys are working on. And in terms of like improving process, how is the Air Force spearheading an expedited joint spectrum approval process?
It depends what you mean by joint spectrum approval. A lot of times you have to get spectrum approved for your bases and things. And so the Joint Spectrum Center actually has to do the approval, and we actually are spearheading a process where we can increase that. We've actually decreased the amount of time actually to do this right now, and the cost already with the Joint Spectrum Office, because we realized that one of the problems we had was it's taking too long. Like it takes a year to get the spectrum approved on the base. We can shorten that now to less than 3 months necessary, and you like this if you're part of the like the 10 bases or the 20 bases that we'll give. If you have a spectrum approval and you have the same spectrum across all those bases, we give a blanket approval for all bases. So you don't have to go through that. All you have to go through is other issues, environmental issues that may be at the base and everything else. Spectrum is very easily get approved now. We sped that process a lot because we knew that was a problem.
Sal, do you have any best practices in terms of organization, sectors sharing spectrum?
Well, I think you bring up a good point, and a great question is that if we look at the experiment that Frank talked about at Tinker that's upcoming, but also just things like CBRS, for example, which is a shared band with the Navy. There are opportunities there, I think, and I think many do, for the public sector to start using that shared spectrum themselves and to take advantage of that. And I think that's going to shed a lot of light onto spectrum sharing, because if you can leverage that spectrum sharing technology mill on mill, if you will, in the case I'm proposing, you might be able to take that model and look at other sharing methodologies let's say in this case, it might be a 5G or LTE device with a naval radar, but in the future, perhaps it's a combat soldier who happens to be using 5G with naval radar or with an airborne asset. And so we have an opportunity now to start internalizing some of the shared spectrum approach within DoD. And I think the prototyping approach is a great way to go that Frank has outlined, because we want to get out ahead of, we want to help shape process and standards. We don't want to keep thinking through this year after year in terms of how we share spectrum. I said, let's get some things out in the field through some of this experimentation and then start looking at, prototyping makes better policy. And we can do that through things like wireless services that are bundled, and some of the spectrum underneath is a mix, but someone's getting a real valued application that's a wireless service, or we can go down the spectrum route, which is we sort of look at it and keep looking at frequency assignments. That hasn't paid a lot of dividends over the past decade. So I'm an advocate of, let's start prototyping, let's start looking at how we can leverage some of this spectrum, shared spectrum within public sector itself. And I think when we get leaders doing that, they're going to start finding solutions to how we can do this writ large.
Great. Got another question. I'll send this over to Frank first, but Owen, I'd certainly love to get your inputs on this. There's obviously, we've talked a lot about DoD base 5G infrastructure and use cases. What is the need or requirement for 5G edge compute for next generation weapon systems currently in development around, JADC2, an ABMS award, or GBSD? And I don't know all those acronyms GBSD is, so maybe somebody could help me there.
So just understand. I mean, we're talking about communication. We're talking about beam steering capabilities as well as everything else. I mean, our whole philosophy has always been, well, why don't we put up a mesh network in the sky, which would connect to the satellites, would connect to the aircraft, and connect to the ground stations. And if you think of it as a software-defined network that exists like on land, except it's in the sky when nodes come in and nodes go out, which are the aircraft or the satellites, everything is consistent across the board. So yes, so when we talk about high density speed that we want, obviously 5G will play a part in that speed, and it depends on where you want to have that speed. Not so much I'm pulling data downwards. A lot of times I'm pulling data upwards, and it's just a question of how we want to play that. And that's what we always talked about. We want to have a grid in the sky, if you will, that basically connects everybody together as a joint player. Because as we do this, obviously you're going to see very fast, I mean, with various weapon systems and everything else, you want to communicate very quickly to everybody that says, here's a problem, move out of the way, or redirect your aircraft a different way right now. And that's what you want to do based upon this advanced concept. And that's why it's, you want to connect everybody together in a very seamless, very straightforward way. And then you have to think about, what intelligence am I going to have on each of these nodes now that actually does that communication and where you want to send everything to. So it's as you evolve, you'll see how this starts playing, that you're going to have a lot of data coming in. And you can look at the Skyborg concept. Basically, it's a drone that has intelligence on it, that actually does scanning and has all the capability on it, but it has to send information to someplace else.
Oh, and anything you want to add there?
I think Frank described it really, really well. I will just, and I don't have anything to add about the Air Force. I will say I'm hearing similar things in terms of what the vision is from other branches of DoD. So I think it obviously the weapon systems change, the people change, the technologies change, but the idea of trying to maintain that mesh of data and ultimately instantaneous communication is kind of the overall vision across the department.
I know we got a ton more questions, and I think if our panelists are open to it, we'll consolidate all of those questions, and maybe you guys could provide some feedback post the webinar, and then we can send that out to attendees, because I think there's a lot of good areas that we could go into. 5G supply chain. We got a number of questions. Is 5G healthy for people?
Usually, yes.
Global 5G networks. But I want to touch on this one because I think we got from the audience, because I think it's interesting. Attendee member noted that, 5G sounds amazing and everybody's like really excited. And it is going to be one of the most transformational technologies ever. But can you talk about it in any information on what 5G is not? Is there something, some sort of expectations that should be set in terms of what 5G can't do? And Frank, you've looked at a lot of these technologies, so I'll look at you first. Is there anything from an Air Force or DoD perspective that 5G will not solve?
Yeah, you got to think of this as it's a technology, and it's not a panacea to everything. And the problem people think about it when they talk about, I have to use millimeter wave. Millimeter wave only goes so far. So for instance, when we want to put flight line of the future out there on the tarmac, which is way out there, 5G only will do so much. It's not going to be millimeter wave unless we start doing some other, but the advanced technology eventually will get us there, but not currently. So don't assume that everything is going to work amazingly well tomorrow. It's going to be an evolution step, and I think people have to realize that 5G is not going to be instantaneously the best thing in the world. We have to look at the missions that are actually going to have to support that, and we're going to have to tune those missions to the spectrum that's going to be utilized, as well as the radio antennas that are coming out.
And Owen, how do you respond to that? I mean, what is 5G not going to solve that, but will maybe even get there eventually, or setting people's expectations?
Well, first, Frank, you're killing me here, because I was about to say it's not a panacea, and you got there before me. I do want to, I want to reiterate. Yeah, this is what we are building is a platform here that will allow people to then innovate in ways they haven't been able to heretofore, just because the infrastructure wasn't there. But that's what it is. It's infrastructure, and it's a platform. And in some ways, I mean, there's been a lot of hard work done already, but in some ways, the hard work of figuring out how do I want to construct my application, how do I want to build systems, that still remains to be done, and some of that innovation still remains to be done. To your point before, I was scrolling through it. There's a lot of really interesting questions about things like UAVs and autonomous cars and those kinds of things. Some of that work still needs to be done in order to make sure that we can control these things. And so that to me is the number one thing. But I think the thing is now the platform is now there for people to innovate and start building, and that's what's really exciting to me.
Yeah, no, that is. So I know we're out of time. I'll just let's do a 60-second wrap. Sal, we'll start with you. If there's one thing that agencies can start to do today to help prepare for 5G and all of the use cases and applications that we've kind of talked about, what would you suggest or provide?
I go back to my opening statement: prototyping makes better policy. You get something going. Get something where you can start working on a couple use cases, test beds, leverage the commercial industry and the innovators, and learn from there.
Awesome. Owen, what would your advice to be to agencies to start to prepare for this evolution?
Yeah, it's that walk then run type of thing. So I would say start looking at where you can get quick wins, right? Fixed wireless is one potential area, and then start looking for potentially like commercial off-the-shelf applications that could start reducing the friction of the processes within your agency. Those quick wins will start getting the buy-in that's needed to get things done in the federal space.
Frank, your advice based on some of the lessons learned that you guys have already had, that where other agencies and organizations can start to prototype, pilot, and what are those crawl, walk, run?
Well, you first have to look at what missions you think you have that need data, that need it quickly. Because this is the data-driven environment. And I think you need to look at the mission level first, and then prototype and see what you actually can get. because that's the way you're actually going to achieve the results that you want to get. But it has to be mission oriented first, because yes, this is the platform that supports everything, but you have to look at what exactly do you need in your field to actually get your job done.
That's great. I want to thank you, gentlemen, again for taking the time out. I want to thank our audience for tuning in, especially I know we're a few minutes over, but I think from the number of questions that we've gotten and comments, it's definitely an area that we need to continue to educate and advance in government. So again, thank you all. On behalf of AT&T, I want to thank everybody as well, and appreciate them underwriting this session, because we wouldn't be able to have it if not. The program will be available to watch on demand, as I indicated. I think we'll try and connect with Frank, Owen, and Sal on some of the questions that we didn't get to, and hopefully get that out to everybody. Otherwise, we encourage you to share this with your colleagues as well. So thank you guys again. Hope you have a great day.